celestial navigation measurement of time. Hopefully you have already watched the video about the sextant. Okay, let's look at the time and why this is so important to working out our position. History. Way back in the 1675, King Charles II built an observatory in Greenwich, England. The purpose of the observatory was to apply with the most exact care and diligence to the rectifying of the tables of the motions of the heavens and the places of the fixed stars so as to find out the so much desired longitude of places for the perfecting of the art of navigation. In 1851, Greenwich was adopted as the location for the prime meridian, the basis of longitude, and this was used in combination with lines of latitude to create a grid over the globe for mapping and timekeeping by nations around the world. All points on the globe are measured from here in degrees, either east or west of Greenwich and north or south of the equator. Time. Okay, so before we move on, if you are a bit rusty on meridians of longitude and lines of latitude, you can read more about them in this blog post about some basic navigation terminology. Greenwich Mean Time, or GMT, was created to observe the average solar time at the location of the prime meridian. So basically the annual average time that the sun crossed directly over the prime meridian at noon, which can be anything from up to 16.4 minutes before or after 1200 noon, depending on the time of the year. Equation of time is the difference in time between 1200 noon and the actual time that the sun's ground position moves across the prime meridian. If you know what the equation of time for any given day is, then you can use that figure to determine when to take a noon sight. More on that later. Or to work out the GHA of the sun at any time. Originally, the astronomers decided that the GMT day started at noon, the time that the sun went over the meridian, while for everyone else our new day starts at midnight. This was of course a bit confusing, so the name was changed to Coordinated Universal Time, or UTC, and the day starts at midnight. UTC is not actually a time zone. It is a time standard that remains constant. There is no daylight savings applied throughout the year. For the purposes of navigation, GMT, UTC, and UT1 all mean the same thing. Time is measured in days, hours, minutes, and seconds. Time also coincides with the passage of the sun. The ground position of the sun moves westward at the following rate: 360 degrees in each day, 15 degrees every hour, 1 degree every 4 minutes of time, 15 minutes of arc each minute of time, 1 minute of arc every 4 seconds of time. The world is divided up into 24 different time zones, as per the picture above. Each zone is measured by 15 No of latitude, 24 time zones, x 15 wound 360 O. They begin 7.5 degrees either side of Greenwich. For every 15 No you travel east or west of Greenwich, you gain or lose an hour of time in relation to the time at Greenwich. Greenwich is Zone 0. Zones east of Greenwich are numbered 1, 2, etc., and the zones to the west of Greenwich are 1, 2, etc. The 12th zone is divided into two parts by the international dateline. The west is 12 and the east is George 12. The zone number indicated the number of hours by which zone time must be increased or decreased to obtain UT. Each region adopts the nearest geographical zone time, ZT, as their standard time. But some areas adjust these times by parts of an hour to get their standard time closer to local mean time, LMT. Many also have seasonal variations for daylight saving and to take in different geographical features. Most boats maintain their ship's time on the local zone time, changing as they move zones. The zone they use is based on their appropriate longitude, as opposed to the local time. You can work out the zone time by using the map table above. You can use the mnemonic. If you are in longitude west, then UTC is best. Longitude east, UTC is least. Here in New Zealand, we are in zone 12. Longitude east, so UTC is least or lower figure, so we are 12 hours ahead of UTC. If you are in America, then you are in the western longitudes. Longitude west, and UTC best, so UTC is better or greater than UTC. So Zone 8, for example, is 8 hours behind UTC. The international dateline runs almost down the 180th meridian, but does some doglegs to ensure that islands belonging to a particular country stay in the same zone. When you cross the international dateline on an easterly course, you take on yesterday's date. When you cross the line on a westerly course, you take on tomorrow's date. Conversion of arc, calculating time. Having an extremely accurate method of telling the time was a huge problem for historical navigators. Mr. John Harrison spent over 43 years working on a chronometer, or extremely accurate timepiece, which was successfully used by Captain Cook on his voyage to New Zealand in 1769. These days, a digital watch can usually be extremely accurate. You can check your watch accuracy by doing a regular time check. In New Zealand, we have pips on the hour on national radio. There is also a continuous time check broadcast on 255, 10, 15, and 20 mHz. Your GPS should also have a universal time reading. Some people prefer to have a stopwatch set at universal time. This can then be stopped at the exact time that you take the sight with the sextant. So what has time got to do with celestial navigation? Okay, imagine that the Earth is stationary and the Sun is revolving around the Earth, moving directly overhead each of those time zones over a 24-hour period. This means that at the equator, the Sun is traveling directly overhead at 1500 an hour, or approx 900 kts. Therefore, to determine our location in relation to the Sun, or another celestial body, when we measure our angle or distance from that body, we need to be very accurate with our time, as because they are moving so fast over our heads, just 1 minute of error of time in our calculations can mean an error in our location of around 15 nm. When you take a sight with your sextant, you will want to also record the exact UTC date and time that you take it. Using a digital stopwatch as mentioned above can be a good idea. Make sure you have got the date right as well. The international date line runs through the middle of the Pacific, so make sure you are recording the correct date. Your sextant readings and time notes should look something like this. GMT, Sunday 22 August 2003. 20 hours 52 minutes, 57 secondes, 41 degrees 23. 20 hours 56 minutes, 06 secondes, 41 degrees 55. We will look at this more detail in the next video. In the next video, we will look at the relationship between the Earth and the celestial sphere. In the meantime, if you want to go back and rewatch the video about sextants, you can do so here.